How's it going? Guys, I went and did it. I'm a sellout. This is the Atom Stack X20 Pro. The reason I caved for this one is it is a diode laser, but it boasts 20 watts of optical power. That's nuts. And it can do all your classic laser stuff. It engraves, it cuts, it rasters. Now, it's not a cheap machine. I think this thing sells for $1,000. They gave it to me for free. But I think it's a pretty decent machine. Now, my question, can we use this thing to melt sand and make glass? Ta-da! So now, we fill our little dish up with sand, treat it nice and flat, and just like that, there will never not be sand in the shop. It's like natural glitter. And now we find out whether I have to send this thing back to Atom Stack or not. Hard to really tell, but it seems something happened. Rescrete and retry. I've gone ahead and mixed the sand with some sodium carbonate to lower the melting point. It doesn't look like much, but it is doing something. So, it seems that 20 watts of optical power is not quite enough to melt sand into glass, which is not surprising. But we're not out of options yet. This is ground glass sandblasting medium. I want to see if we can make this work. As you can see here, I've gone ahead and 3D printed a new shroud for this that directs all the exhaust air upwards. As you can probably also see, that is some horrendous print quality. I put a 1mm nozzle on my printer and I just can't go back. Gotta go fast. Anyway, let's try this. We got something. No way. That almost makes me think that this is viable. It's not as brittle as the sand. It's actually a solid piece. Holy. All right. That is glass. Now maybe the fact that this tiny little success is enough for me to take on a week of work says something about my psychology, but we're doing it. So clearly this project is very much inspired by Markus Kayser with the Solar Sinter project. I can't help it. It's just so cool. So basically what I'm going to be doing here is making an SLS printer. Now, with the laser cutter, I'm just going to keep the XY gantry from this intact. That saves us some work, at least for now. So the only part that we need to make is the powder extruding and leveling system. And I don't have a plan for this, which I'm sure you're not surprised by. So, we're winging it. So here we have the base of the machine. I'm really sticking to the old KISS principle here. Basically, it'll work like sand go up here, sand go down here. Simple. Now that half a second grinding clip that you just saw doesn't really do justice to the amount of grinding that I've done on this thing, because these need to be perfectly flat. And I've honed it in pretty close, but I'm still not quite happy with it. So I think I'm gonna bite the bullet and take it to the local machine shop to get it milled flat. There's no way I'm fitting this big old thing into my mill. So I'm going to take this over there, and depending on the cost, I'll either come back with a beautifully machined surface or an iron determination to do this with a grinder. I'll be back. And I'm back. You know what's cheaper than machine shops? Iron determination and clever fixturing. Let's see if we can do this ourselves. I don't know what I was being such a baby about. I forgot I can pull the entire head of this thing up. Now, let's get this thing milled. Bam! Well, that was Chatter City. That little mill gets mad at me every time I feed it steel. But I think it did an okay job. Screw the machine shop. Now then, I've cut out these pieces, and I'll use these to 1, mount the linear rails using these tapped holes, and 2, create a bit of a lip to keep all the sand inside here and not falling out onto my motors and whatever. So, let's weld these up. Yeah, I finally caved about the fireball square. That guy's like a marketing genius, man. Every video he puts out, I want to buy something from him. So So I'm thinking I want to pull this thing around with a lead screw, in which case we need a place to mount our pillow block bearings. So I guess I'm just going to frame this whole thing out. Now we got to start working on the wiper mechanism. So I printed out all these parts. These guys go together. These guys are both to add a little bit more meat where I need to tap these holes for the pillow block bearings and also to position them all correctly. Beautiful. So now with a pillow block bearing installed here, these should line up just perfect. So now with the pillow block bearing and a couple spacers installed, these line up just perfect. Nice. Now for our gantry, I've got this piece of flat bar. I've got it reasonably squared up. So I'm gonna tack this in place. I know I said tack. I got a little trigger happy. It's fine though, look at that. So initially I wanted to just attach this with machine screws to leave it somewhat adjustable, but everything's looking nice and square. So I'm gonna trust it. Not trusting it too much, they're just tacks, but we'll see. So our little wiper works pretty well, surprisingly. So now we got to start thinking about the platforms that are going to push the sand up and down. And these have to be pretty tight tolerances because we need it to slide freely but not let any sand fall through. And tight tolerances are my worst enemy. So I brought the old Burninator out to play. What I'm gonna do, I'm gonna melt a bunch of aluminum and then I'm gonna cast it in the drop from that square tube we use for the chambers. We'll see how this goes. Well, I tried swapping the heating element in this guy a little bit ago and it seems it was not up to the task. So I think we're gonna have to resort to old, loud, but reliable. Wow, that didn't turn out too bad. I got two horrendous surfaces on there, but it doesn't matter, we're just pushing sand. What matters is these dimensions will fit up perfectly inside the tube. I'm hoping with minimal sanding because of how much it contracted as it cooled. In order to move these platforms up and down, I've cut out all these parts on the plasma cutter. Let me stick them together, then I'll show you my thought process. So here we have our finished part, two of them. These will mount on linear rails underneath the main chamber. This is where I'll be mounting the lead screw, or rather the ball screw. I went fancy for this one, guys. And then on the top is where our big aluminum chunk will mount. So in order to mount these big boys, I've drilled and tapped holes for linear rails into all these pieces of tubing. These are gonna go on just like this. Just like. Oh boy, this is it. Well, there's something I didn't think about. Hey, okay, we're going backward. It looks close. Still gotta put some hardware in. I'll be back. Well, I seem to have a bit of a problem here. These work wonderfully, but once I attach the aluminum, problems ensue. As you probably can't see here because it's dark and I don't have a light, once I fasten the aluminum to our little dolly things down there, it twists a little bit and binds up. But that's not the problem. That can be fixed. The problem is these gaps. They're much bigger than the particle size of the sand that I want to use. I guess the aluminum contracted a lot more than I expected it to from casting it. So this isn't going to work at all. Yeah, I need to come up with a better solution. But of course, the road to a better solution is paved with much worse solutions. I tried everything, man. I made the platforms out of wood. I cast resin for the platforms. I tried spray foam. Yeah, spray foam. I tried making a spray foam gasket. I tried cutting platforms out of HDPE. I 3D printed it. I made a funky little laser cut compliant mechanism. But here is what I landed on. And yes, you better bet that is the Who blanket. So now, I take these guys, go crazy with the contact adhesive, and glue this strip around the edge. And this is effectively my low friction gasket. As you can see, with this thing installed, it works. Now, is it perfect? No. Is it close to perfect? No. Is it 1,000 times better than anything else I tried? Yes. So, I think we have a winner. So in order to mount these ball screws, got me another pile of 3D printed parts. 2D plasma cutted parts. I don't know what I'm doing. So I designed these in a way that they're all indexing off of this tube. So if this tube is out of square, everything's out of square. But at least we'll be following the linear rails. So let's throw these on. So now we can take our ball screw and get it installed. Now we know where this is supposed to be installed. I'm going heavy on the anti-spatter spray. And now, much like the rest, we line up our stepper just like that. This block goes right in there, and that is what couples our ball screw to our, is it a gantry? Either way, that's what we're calling it. Beautiful. Now we spin ball screw, gantry move. Very nice. So I've gone ahead and installed the ball screws on both sides. I've also installed a lead screw for this. And initially I was gonna have 2 of them, but I think it's just fine with 1. That thing is pretty dang rigid, so I don't think there's gonna be any racking. Look at it go, wow! Now then, in order to complete this printer, we just gotta take this and stick this on it. So now we take our little hat, somehow stick it on the machine. I need a third hand. And then this hat gets another hat. Ta-da! As you can see, perfectly functional. Doesn't look ridiculous at all. Right? Right? It's nice. Well, would you take a look at this thing? This looks a bit ridiculous, huh? It's like a spider wearing a sombrero. Whatever. What's done is done. Now, all I gotta do is install the electronics, and I think we can give this guy a test. So I'm mid-wiring this thing up, and we got a problem, guys. In order to fix this problem, I chose the fix it with money route. Here we have a gearbox. And here we have a gearbox installed on the machine. It works! Ta-da! Just like that, everything's all wired up, ready to go. So you guys know the drill with these experimental printers. Now, we print barnacles until I button down the print settings. Well, I think our barnacle prints have gone quite well. Look at this nice little cinnamon bun. So cute. As you can see here, we actually have layer adhesion. I even tried to take a wire brush to it to try and clean it up, and it didn't break. I think we got our settings buttoned down. So you know what this means. Time to start a full day print. Oh my God. Look what happened. We got caught up in the screeder and shoved to the side. Oh, it was like halfway there, man. Wow, that was disappointing. The print failed like 8 hours in. Yay! Not only did it fail, it got dragged to the side and crushed, so I didn't even get to see how good it was. Yay! Since then, I've gone ahead and printed more barnacles. I think I got to a print setting that I'm reasonably happy with, and I feel reasonably more confident about. Also, in order to better monitor this thing, I've got an ESP32 here. And this is hooked up to this limit switch. So now, whenever this switch is hit, it'll send me a text. This switch will get hit by the screeding mechanism on each layer shift. So that way I can, you know, sort of better keep track of it. Now then, back to your regularly scheduled montage.
So good.
Would you look at that? Not too bad. We've suffered some minor damage to the hull. Overall, maybe not the prettiest benchy in the world, but for a proof of concept, dig it, man.
Well, it's hard to position the camera over this unruly thing. I think we can call this a success. Definitely got its issues, the biggest of which being, I don't know if the print's working until it's done, or it crashes. I had so many failed prints on this.
Here's our little ship graveyard of all the other failed prints. It took a while to button down those settings.
But, as a proof of concept, I think it did okay. Now, ways to improve. It'd be sweet if the screeding mechanism could lift up on the backstroke, and I also noticed in my further research, a lot of the real SLS printers have a rotating screeding thing. Not sure why, but probably worth a shot. Also, a higher power laser would definitely help quite a bit. Although, the little atom stack really was a trooper, man. I was a little worried about the duty cycle of the thing, but eventually I said, screw it, let it run all day. No problem, for multiple days. I'm clearly not going to be printing myself any vases anytime soon, but as a proof of concept, I think that worked great. But yeah, that's what I got for you this time. If you like what you saw, leave a good old dinger. Think about subscribing, and thank you for watching. Hey, and now I got an SLS printer. Let me know if you guys got any other funky ideas that I could use this for. Thanks for watching.